Alright you guys, in this video we're going to be introducing the topic of stoichiometry, and in order to do so I'm going to be showing you a fun example and it'll show you exactly how stoichiometry works. And the goal behind stoichiometry is using the stoichiometric coefficients of a chemical reaction to determine the relationship between two either reactants or products, and showing the relationship between the two. Alright, and here's how the example works. I want you to pretend you guys are a forensic scientist and you're investigating a murder. And the murder involved the victim being poisoned with a substance known as dichlorobenzene, which is C6H4Cl2. Okay. And when the autopsy returned, there was 27 grams of the substance found in the victim's body. But more than likely there was more of this present before the chemical reaction took place because of tissue absorption, etc. Now, when you start your investigation, you interrogate a couple suspects, and one of the suspects that you interrogate is the victim's husband. Now, the victim's husband is a high school chemistry teacher, and what he does in his defense is shows you two bottles. He shows you a bottle of benzene, which is C6H6, and he tells you that originally there was 15 grams of it that he used to react. And what he tells you in his defense is that he used the benzene to create a compound known as methylbenzene or toluene, that is C6H5CH3. And he tells you that he made 24 grams of it. Okay. And he also tells you that toluene is an innocuous compound, so it would not do any harm to the victim. So your goal here, your job, is to figure out if the 15 grams that he reacted of benzene made either 27 grams of dichlorobenzene, or if it made 24 grams of toluene. Okay? And here's how you do this. We're going to set up two chemical reactions, and each of them are going to show us from the benzene reacted how many moles, which we can eventually convert into grams, are created from the original substance to the product. And here's what I mean by that. So the first reaction we'll take is he took C6H6, combined it with CH4, which is methane, and created C6H5CH3 plus H2. Okay. The second reaction we're going to look at is the reaction of C6 plus chlorine gas to create dichlorobenzene. Now, what I want you guys to notice in these reactions is the numbers that indicate the stoichiometric coefficients are not present. The reason for this is when there's no number here in front of the reaction compound, we can assume that the amount of moles is 1. So, illustrating that, okay, so now what we can do is we can figure out how many grams of C6H5CH3 was created based off of 15 grams of benzene reacted. So what we can do, as we did before, is we'll convert grams to moles. And the molecular formula, or the molecular weight of benzene is 78.11 grams per mole. Alright, again guys, I cannot stress enough, make sure you keep your units here. This is really important because you're going to be canceling out a lot of units. So So now we have moles of C6H6. Now we can look at the ratio of the two. For every mole of C6H6, I get 1 mole of toluene created. So we can use that to convert from moles of C6H6 to moles of C6H5CH3. In doing so, we cancel out this, and now we're at moles of C6H5CH3. What we can do now is, we have moles, we can convert to grams. So this is C6H5CH3, and the molecular weight of toluene is 92.14 grams per mole of C6H5CH3. And again, your units will cancel. Okay, so now we can plug and chug the numbers. Let's say 15 divided by 78.11 times 92.14, 17.69 grams. Okay, so he stated that he made 24 grams off that, but right now we see that he made almost about 17.7 grams. Okay, so right now, as far as we're concerned, he's not telling the truth. His defense is inaccurate. But let's look at reaction 2 just to make sure. Now we're going to look at the same thing again. We can look at the coefficients of this reaction as 1 because there's no integer in front of them that tells us otherwise. So we can presume that this is 1. Okay? We'll do the same thing as we did before. We'll take 15 grams times 1 mole of 78.11 grams. Again, we can use the stoichiometric coefficients to convert from 1 mole compound to another. So we can say that 1 mole of C6H6 is equal to 1 mole C6H4Cl2. Okay, and we'll do the same thing as we did before. We'll multiply by the molar mass of dichlorobenzene, which is 146.998 grams per mole of C6H4Cl2. And we'll plug and chug the numbers. It's 28.22 grams. Now, when we talked earlier and we said prior to the investigation that if you can prove that 24 grams of toluene was created, then he's innocent and he was telling the truth. But if about 27 grams of dichlorobenzene was created, then he's lying and he is the murderer. When we looked at this formation of toluene, we only created 17.69 grams. So that was inaccurate. He was not telling the truth on that account. Furthermore, 15 grams converted to grams of dichlorobenzene created 28.22, and originally we stated that there was probably more because of tissue absorption from the original amount giving us 27 grams. So it makes sense that we had a little bit more than 27, which concludes that he was indeed the murderer. Okay? And again, guys, one of the most important things to keep in mind here with this question is your units. We're going to go from grams to moles of the reactant, to moles of the product, to grams of the product. Okay, and that's what helps us determine the grams of a product from the stoichiometric coefficient of a reactant to a relationship of the stoichiometric coefficient of the product. Okay? Alright, if you guys have any questions, please do not hesitate to contact me. Alright, I'll be doing several more examples of these, but I thought this was a fun example to show you. So, hope you guys have a good day. Thanks for watching.